0 is included with the natural numbers. So the whole numbers are 0, 1, 2, 3, and so on. After that, there comes some rational numbers. So rational numbers are the numbers which are in the form of p by q, where q and p both are integers, but q is not equals to 0. There comes irrational numbers also. So irrational numbers are the numbers which are not in the form of p by q. There may be some decimals as 1.2222222, where 2 is repeating again and again. So this is a kind of irrational number. Other irrational numbers are in the form in roots as well. So basically we can say that irrational numbers are okay. So basically we can say that irrational numbers are the numbers which are not written in the form of p by q, and where p and q are integers. So some examples of irrational numbers are root 2, root 3, pi, or it is. If we want to represent root 2 on a number line, what do we need to do is that we will consider a square with each side 1 unit in length on a number line. Then we can see by the Pythagoras theorem that the hypotenuse of that the diagonal of that square is representing the hypotenuse of a triangle. So how can we represent the hypotenuse of the triangle on a number line? Let's say we are having a square. This is the square. And its length is of 1 unit. If we draw a diagonal, let's say it is the hypotenuse of these two right angle triangles. So in this right angle triangle, the side length, the hypotenuse is of unit 1. Pythagoras theorem, we can know that the length of hypotenuse is root 2. So if we divide 10 by 3, do we get a perfect integer, a number which is an integer which has no decimals? No, because when we divide 10 by 3, we will get a number which is 3.3333 and so on. So the number 3 is repeating again and again. Now let's take another example where the fraction is 7 upon 8. So if 7 is divided by 8, we will get a number which is a decimal and whose value is 0.875. Let's take another example which is again a fraction 1 upon 7, and when we divide 1 by 7 we will get 0.142857 and so on. So these are the three types of fractions which we have solved and get what will it result with. In the first one, we got a remainder 1 and then we put a decimal. Again we got remainder 1, so the divisor was 3. So we noticed here that the remainders either become 0 after a certain stage or sometimes it start repeating themselves. In the case 1, we got the remainder was repeating itself. Again and again we were getting the remainder as 1, 1, 1 and 1. Also, the number of entries in the repeating string of remainder is less than the divisor. In the first one, where we divided 10 by 3, one number repeats itself and the divisor is 3. And in the third example, where we divided 1 by 7, there were 6 entries, which were 3, 2, 6, 4, 5 and 1 in the repeating string of remainders, and its divisor was 7. So if the remainder repeats, then we get a repeating block of digits in the quotient. Let's say when we divided 10 by 3, 3 repeated in the quotient, and for when we divided 1 by 7, we were getting the repeating blocks 1, 4, 2, 8, 5, 7 in the quotient. When the remainders become 0, let's say in the example 2, where we divided 7 by 8, we got its result as 0.875. So in this case, the remainder was actually became 0 at a certain point. And similarly, we can have some other example also. Let's say we take an example of half. Here also we get a remainder which becomes 0 after first step. So in all these cases, the decimal expansion terminates or ends after a finite number of steps. So when it terminates, we call the decimal expansion as numbers terminating. And the case where remainder never becomes 0, we say these expansion as non-terminating recurring. Let's say this one is non-terminating. Let's take an example. We need to show that 3.142678 is a rational number. Or we can say that we need to express the number 3.142678 in the form of P by Q, where P and Q are integers and Q is not equals to 0. form of rational number. So in this case, what we are going to do, we will first remove this decimal point and write the number as 3142678 divided by and hence it has become a rational number. Because in this case the number is in the form of p by q, where p and q both are integers. Also, let's take another example where we need to show that 0.3333 and so on can be expressed in the form of p by q, where p and q are integers and q is not equals to 0. So here we don't know what 0.3 bar is. These kinds of number can be written as a bar in the above the number. So we don't know what this 0.3 bar number is. So let's call this number as x. Now let's say we are multiplying 0.3 as with 10. So 10x is actually 10 times which means when we divide a decimal with 10, the digits gets moved to the left, so the number has become now 3.333 and so on. And solving for x, we will get 10x is equals to 3 added 0.3333 so on. So we can say 10x is equals to 3 added x again. So it becomes 9x is equals to 3. Again we are solving for x, so x is equals to 3. And hence we have represented the number 0.3333 so on as a rational number, which is equals to 1/3. Let's say we need to find some irrational numbers. We need to find an irrational number between two numbers. So how can we get an irrational number between two numbers? Let's have an example. Let's say we need to find an irrational number between 1/7 and 2/7. So we know that 1/7 in our